Okay, we're going to take a look at the perpendicular bisector theorem here, draw some perpendicular bisectors, and take a look at a fun application. My objective is that Math Bridge 1 students can construct perpendicular bisectors and apply what they know about the perpendicular bisector theorem that we learned about in the last video and is in your book to make logical deductions. Okay, so our challenge, and this is based on the performance task in your book that you're going to actually do for homework as well. Our challenge is to construct a radio television transmitter that is exactly equidistant between Elk Grove, Sacramento, and Davis. And I've drawn a rough triangle here showing that Elk Grove is mostly south of Sacramento, and that Davis is a bit north and west of Sacramento. Not a perfect map, but let's assume it is for the purposes of this math problem. And this seems like the kind of thing that would require some fancy civil engineering to do, figuring out the exact right location for the radio television transmitter. But it turns out that we can do it just using the method of constructing perpendicular bisectors. So let's check it out. I don't have a compass here, so I'm not going to be able to make exact perpendicular bisectors, but we can take a good guess here. So let's say that I look first maybe at the distance between Sacramento and Davis, and here maybe is the midpoint. And I'm going to kind of fiddle around, and looks like this would be perpendicular here. Again, this is pretty loose. Then we're going to head out this way. All right, and I'm going to pick a different color, and then we're going to make a similar bisector between Sacramento and Elk Grove. I'll do that in this sort of more purple color. And I'm going to try to guesstimate maybe right there. It looks pretty close. So I'm going to go out here. And that way, perhaps not quite perfect, but notice that eventually these two perpendicular bisectors are going to cross. And then if we did the same thing and drew a bisector, I'll do this one, I don't know, perhaps in kind of this darker purple color. If we went from here, we could draw a perpendicular bisector that's going to end up in the same spot. Okay. And amazingly, the first thing I want to point out here is that this place here, off in the countryside, off in somewhere in Yolo County, is going to be the perfect spot for our radio transmitter, which if you ever drive up I-5 and look for the radio transmitters to the west of Elk Grove, you'll see that actually this is the spot where the radio transmitter exists. So we'll call this M. All right, so what I want you to do, and I'm going to pick a different color, and to think about is this perpendicular bisector theorem. And then let's focus just on the Davis to Sacramento to begin with. Now what the perpendicular bisector theorem says is that if this pink line here is the perpendicular bisector of segment DS, then the distance from M to S there, and the distance from M to D here is going to be exactly the same. Yeah. What it also says is that's going to be true for the other bisectors as well. So let's take the bisector between Sacramento and Elk Grove. And we already have actually the distance from M to Sacramento drawn in. but we're also going to draw the distance from M to Elk Grove. There. And so this is the same. This is the same. Okay, and that we this looks to be also the same. But let's look at the logic, or one version of the logic. I think this is pretty cool. This is something my son pointed out to me, actually, is that we can apply the transitive property here. His name is Simon, by the way. This is my older son. So if we look at line segment MD, we know by the perpendicular bisector theorem that the measure of MD is going to equal the measure of MS. That's by definition, using logical deduction and just basing our knowledge off the perpendicular bisector theorem. Same thing here with MS. The measure of MS is going to be the measure, the same as the measure of ME. In other words, the distance from the midpoint to Davis is the same as the distance from the midpoint to Sacramento. The distance from the midpoint to Sacramento is the same as the distance from the midpoint to Elk Grove. And what's cool is using the transitive property, we can see that the measure of the distance from the midpoint to Davis equals the measure of the distance from the midpoint to Elk Grove. So in this case, it does not take a fancy degree in civil engineering to figure this out. We can figure this out taking our middle school math class. And pretty cool, and a good example of the perpendicular bisector theorem and some of its applications. Thank you.